In this example, we're going to show you how to take the model of the Magic Beans coffee sign, and we're going to walk through the various stages to create the toolpaths to cut the finished sign that you can see here. So let's go to File, Close. So let's go and open an existing file. So from the Magic Beans Coffee Sign project folder, we're going to open the Magic Beans Coffee Sign 3D modeling file where we left off in the modeling tutorial. So we use the open option to open that up. Okay, so here is the model. Let's just use this option here to tile our windows vertically. That way we can see the 2D view on the left, and we can also see the 3D view on the right hand side. So we're going to look at machining this sign as efficiently as we can. Okay, luckily for us, our sign is fairly flat, and we're also going to look at using flat stock material. And so the only area that would need to look at 3D machining would be the border of the sign, as well as the two recess areas that we have over here. Now when we 3D machine anything, what happens is the centre of the tool cuts up and to the vector boundary. So in the example of our border, if we just zoom in to the border vectors here, so we're going to be machining in between these two vectors, as that's the only part that is actually 3D. We don't need to machine onto this area, as this is flat. This will be the top surface of our material. Okay, and so the centre of the tool will machine up to this vector, and in terms of this area here, that's going to be okay because we've got a flat top. Now as the tool is rastering back and forth, working its way to the edge of the sign, as it gets to the edge to this vector here, the centre of the tool is just going to follow along this line, okay? And so we'll find that we're not actually cutting all the way down the side of our model. And so to overcome this, what we need to do is look at creating an offset just to bring this out a little so that our tool can roll past the edge of the part and cut down at the side of our sign. So to do that, we're going to take this vector. If we just use this option here to zoom active view to our drawing limits, we'll put that back in Z, and then with that vector selected, we're going to go over to the offset tool. We're going to offset this outwards, okay, and we're going to offset it by 0.15 of an inch, so a little bit larger than the radius of the tool that we plan to use. I'm going to uncheck this option to create sharp offset corners, and then we can press offset. Okay, so let's close out and we can see we've got our vector there. So now we're going to use this vector here along with this vector, and we're going to machine everything in between, and by creating that offset we're actually allowing the tool to cut down the side of our sign. Okay, so let's just use this option here to zoom active view to the drawing limits. So now we have everything ready, we can go ahead and start to create our toolpaths. So let's switch over from the drawing tab over to the toolpaths tab. And the first thing that we must do is set up our material according to how we're going to set up our material on our CNC machine. Okay, so we're working with a 1-inch thick material. Our XY datum position, I'm going to change that to the lower left hand corner so the X0, Y0 origin is down here. We're going to set the Z0 off the material surface. Okay, then we need to specify the model position in the material. Now, as I said, as we're working with flat material, we're going to make sure that we push this model all the way up to the top surface of our material, which we can see here. Gap above the material is shown as 0, so we know that the model is right at the top surface of the material. Then check over your rapid Z gaps above the material, ensuring that your clearance and plunge settings are safe and appropriate for your setup, along with your home and start positions, in which case I have mine set up at X0, Y0 with a safe Z gap above the material of 0.5 inch. And then you could go ahead and press OK. So the first toolpath we're going to look at creating is a 2D profile toolpath. We're going to use this toolpath to machine the hanging holes for our sign. So first thing we need to do is select the vector. So we're going to select this hole here, hold down Shift, and we'll select this vector also. So now they're both selected. Okay, we're going to assign a start depth of 0, so we're going to start from the top surface of our material and we're going to cut all the way through our material. So you can type in Z equals and the software will enter in the value that you assigned as the material thickness within the material setup form. So that's just an easy shortcut for you to remember. Okay, so that's going all the way through. Next thing we want to do is we want to look at assigning a tool. Okay, so we can look at the tool database by using the select option here. Okay, in this case we're going to look at using a 1/4 inch end mill. Okay, so the settings that we have here are fairly conservative for the type of material that we are cutting into, so I'm just going to select that. However, I do feel that maybe we could look at just increasing our pass depth, as well. We're only working with a small area, so I can afford to just edit the pass depth for this particular tool, but just within this toolpath. And we do that by using the edit option here, where I can just edit the pass depth here, just increase that so it's 1/4 inch, then we can OK that. And then we can use the machine vectors option, where we're going to machine on the inside of those vectors to cut the holes out. And then we can give that a name and we'll just simply call that profile and hanging holes. And then go ahead and calculate that so we can see the toolpath it's going to take from our X0, Y0. It's going to travel over and then it's going to cut down in passes of 1/4 inch until it cuts the part out. So that's 4 passes there. And it will move on to the next hanging hole and complete the cutout there. Okay, so we can preview that and you'll see that we are left with a small bit of waste material. I don't think that's going to cause too much damage to our tool or the extraction system. So I'm just going to go ahead and keep this as it is, and then in terms of the simulation, we're just going to double click on the 2 areas just to delete that waste area. So let's close out of the preview toolpaths form, and now we're going to look at creating a 3D roughing toolpath for the border and the recesses. Okay, so we're going to select the offset vector that we created at the start of this tutorial, hold down Shift, and we're going to select this inner vector here, Shift and select the outer circle, the inner circle, and then the circle that represents the central motif here. With those vectors selected, we can now go into the 3D roughing toolpath. So as always, we first need to select a tool. I can see here we've already got a 1/4 inch end mill assigned to this toolpath. Okay, that's the tool that I actually want to use. So I'm going to use the edit option just to check over the settings, ensuring that they're safe and appropriate for this particular toolpath. Okay, we've got pass depth of 1/8 inch, so I'm happy with that. So we can go ahead and press OK. Next up, we need to specify our machining limit boundary. So we're going to use the selected vectors for our machining limit boundary. We're going to machine everything in between the vectors, where we're going to have a boundary offset of 0. Okay, remember we already offset out the outer vector to create the offset so the tool can roll down, and everywhere else is either flat or is a negative shape, so we needn't worry about an offset there. Then we move on to the machining allowance. So here we're just going to go with 0.03, which is just a skin of material that we're going to leave on the surface after the 3D roughing toolpath is finished. And this just makes sure that we have some material left for the finishing toolpath to cut, and it keeps that roughing tool away from the finished surface to make sure that it doesn't chip it. So the next option we have within the form is the roughing strategy. And this is where we tell the software how we want to machine those 3D areas. We have 2 options, sea level and 3D raster. In this case, we're going to go with a Z-level strategy, so we're going to use 2D toolpaths to cut out the 3D parts. We have further options within the form to really control how we cut that strategy. For example, we have the order. We have two options, level by level and depth first. So level by level, it means that it will machine all the different areas to a fixed level or past depth of cut. So for example, we have the border, we have the recess with the text, so the internal areas of the text, and we have the dish itself. And so it could start at the border and it will machine the first past depth for that border, move on to the recess, run the first past depth for the recessed areas and the text, and then move into the dish and run the first pass depth for the dish, move back to the border, onto the second pass, and so on. And so by using this option, we're creating quite a lot of travel between the different regions as we move down in the pass depths. The other option we have is depth first. And so this option will allow us to machine regions at a time. So for example, it could start with the dish and it will just machine everything out for the dish, move on to the recess and machine everything out of the recess, and then machine everything for the border. So generally this would be quicker as there's just less travel between each region. Okay, so we'll go depth first in this case. Raster direction, we're going to do that along X, so it's going to go along the X axis. We're going to assign a profile to go last after every pass just to clean it up. Okay, so moving on down, we could go ahead and give our toolpath a name. In this case, we're just going to call that one 3D Roughing, and then we could go ahead and press calculate. That'll calculate that for us, and then we can simply go in there and preview that toolpath to see how the part looks. Okay, so that doesn't look too bad. So now we can safely go in there with a smaller tool to get all the detail out using a 3D Finish Toolpath. So let's close out of there and we're going to go into the 3D Finishing Toolpath. So the first thing that we're going to do is select a tool to apply to our Finish Machine Toolpath. So we're going to go with an 1/8 inch ball nose. You can check over the settings, ensuring they're safe and appropriate for your machine. And then we can go ahead and press select. Machine and limit boundary, we're going to again use the vectors that we currently have selected. We're going to have a 0 offset. We do not need an offset in this case. Then we move on to the area machine strategy. Okay, so we have a raster options that will just go back and forth along an axis, and then we have the offset strategy that will start in the center and it will work its way out. Now, given the shape of the job where we've got a border and circles in the center, I feel that this offset strategy will give me a much better finish than if I was to go back and forth with the raster strategy. So we're going to use the offset option there. Give that a name and we'll just call that one 3D Finish and press calculate. Okay, so the software is just going to take a moment to calculate that toolpath for us, and then we'll be able to preview that in the toolpath preview form. Okay, so here it's automatically opened the preview toolpaths. We can see the toolpaths here, and then if we go ahead and preview those, we can see how it's going to cut the part out. Okay, so I like what we've got there. Now, if you felt that there wasn't enough detail in here, then you could go back into the toolpath, the Finish Toolpath itself, and then alter the settings of the tool. Maybe you could decrease the step over or look at using a smaller tool, but here I think we've got enough detail in here that it's pulling everything out, so I'm satisfied with what we've got there, and we can look at moving on to the next part of our design. So let's close out of the preview toolpaths form. Now we're going to take the magic beans text, okay, and we're going to run a vcarve toolpath on that. So starting at the top, we're going to look at the depth. So the start depth is going to be at 0, the top surface of my material. Then we need to choose a tool. So let's use the select option to open up the tool database. Okay, so here we have a selection of V-bits. Now the V-bit that I'd like to use is a specialist sign making tool. It's a 120-degree V-bit, and we don't have that here in our tool database, so we're going to look at creating a new tool to add in. Okay, now this new tool will be appropriate for my hardwood material as well as my large format machine. Okay, so we're going to actually take the 90-degree 1¼ inch shank V-bit, and we're going to copy that, as my 120-degree bit also has a shank of 1¼ . So with that, we're going to use this option here to copy the selected tool. Okay, and then over here we're just going to change the angle here, so we're going to make that 120, and you'll see now I've typed that in, it's automatically updated the name over here. And we're just going to copy the settings from the 90-degree 1¼ tool, press copy, and that will open up all of the parameters here where we could look at changing those according to the specs of the tool itself. Okay, so these settings seem okay, so if we go ahead and press apply, you'll see that the software has prompted us with a message telling us that the pass depth of ½ inch is greater than the tool maximum cutting depth, and that really maximum pass depth for this tool is 0.361 of an inch. Okay, so we just need to alter that. So let's just go with a pass depth of 0.3. Okay, now if you are going to run this, then you need to ensure that the settings are safe and appropriate for your setup. So be mindful that you check over the settings and change them accordingly. Okay, so we'll go ahead with that. So we'll just apply that, the changes that we just made to the pass depth, and then we're going to select that tool to use. And then we could go ahead and calculate that. We can see the preview of the actual path itself, and then we can preview how the part will be simulated into our material. Okay, perfect. I think we've got a good effect there, so let's just put that back in Z. We'll close out, and now the last thing that we need to do is just run a profile pass to cut our sign out of our material. So in the 2D view, using the scroll of my mouse, I'm just going to go in there to get the vector that represents the outline, and then we're going to go over into the profile toolpath form. So our start depth will be at 0, the top surface of our material. Cut depth, we're cutting all the way through, so we're going to leave that at 1 inch. We could choose a tool. I can see already we have a 1/4 inch end mill in there, so let's use the edit option just to check over the settings. Okay, so we have a pass depth of 1/4 inch, which is okay, so it should cut that in 4 passes. And we're going to machine the vectors on the outside. Okay, so it's going to go on the outside of that vector. If we wanted to, we could add tabs to the toolpath, but let's assume that we have a system that holds our material down to our spoil board, and then we could give that a name, so we'll just call that one profile, press calculate, and then we can preview that toolpath, maximize the 3D view, and there we have our cutout. If you wanted to remove the waste material, simply double click on that and that will delete it. So the preview looks good. Now if you found that you didn't like what you had in the preview, then like I mentioned earlier, go back into your toolpaths, alter the settings until you're happy with how the software is simulating your preview before you go ahead and run that on your machine. Now in this case, I think our sign looks good, so we'd go ahead and start saving out our toolpaths to run onto our machine. So go into the Save Toolpath form, and then we'd select the profile hanging holes and the 3D roughing, and we can see that they are using the same tool. So we could check this option here to output all the visible toolpaths to one file, and then save that out, and then we'd continue through the form, saving out the other individual tools, in which we can then go ahead and run those toolpaths on our CNC to cut the Magic Beans coffee sign out. Okay, so at this stage, let's go ahead and save our file. So we'll go to File, Save As, and in the Project folder, we're going to call this one Magic Beans Coffee Sign 3D Toolpaths. Press Save, and you can access that from that project folder.